So let's talk 36. What can you do to 36? So 36, the question says, oh, what happened on my book? Switch pages on me. 36 says x squared y to the third over a squared b to the third. What can you do to that? There's not a darn thing you can do to this. So guess what the answer to this question is? It's x squared y to the third over a squared b to the third. There's nothing you can do. You can't always simplify things. Sometimes things are already simplified. It is what it is. What's 39 do, though? So we got c squared a to the third over a to the fifth, all raised to the second power. There's a couple different things we can do here. What's one of them? Raise everything to the second power? Get rid of the powers raised to powers? Absolutely could do that. So what would the c be raised now to? What do you do with powers raised to powers? So what's 2 times 2? 4. This a would be raised to the 6th. And then this a would be raised to the 10th. Now what should I do? I have a's on top and a's on bottom now, don't I? What do I do when I divide with these? Subtract. So how many a's am I going to be left over with? 4 of them. Where are those leftovers going to be? On the top or the bottom? So my answer should be c to the 4th over a to the 4th. This is what your answer should be. Now, could I have subtracted first? Before you do powers raised to powers, could I have left that 2 alone, leave that c squared here? Could I have reduced here? Yeah, I got 3 a's on top, I got 5 a's on the bottom. Subtract. How many a's would I be left over with? 2, and where would they be left over? In the bottom. But now I got to do powers raised to powers. And what would I end up with? Wouldn't I end up with the exact same thing? Does it matter which order you do these? No. Here's the thing. All of those rules can be used in any order. You can do whatever you want, as long as you don't break one of those rules. As long as when you see powers raised to powers, you multiply. As long as when you divide the same base, you subtract. It doesn't matter if you do that first and then do powers raised to powers or do the powers raised to powers. So you can do it in any order. So that's what's going to help you. Okay? Are we good with this one? All right. Which one are we at now? 42? So you got b to the negative 2 over b to the third, all raised to the second power. Well, we got 2 things going on here. We got a division. We also got powers raised to powers. What do you want to do first? Division? Or, another thing you can think of, I got a negative exponent. What else could I do with this negative exponent? Flip it, put them in the bottom. So what should I do first? Flip it? Great. These b's go where? In the bottom. So I've got those 2 b's go to the bottom. These 3 b's, do they move? No, that's a positive 3, isn't it? So those b's stay where they're at. So I'm left with that. Now what do I use? What do I do with something like this? You can add those, right? So now, I got a 1 on top. How many b's do I really have on the bottom now? 5 of them. Raised to the second power. What's 1 to the second power? Emily, please put that away. What's 1 to the second power? 1. What's b to the 5th to the second power? B to the 10th. So there's your answer. Now again, it doesn't matter if you want to do something different. You also could have took powers raised to powers right away and said that's the same thing as b to the negative 4th over b to the 6th. You could even use subtraction now here. That's the same thing as b to the negative 4 minus 6, right? Because division means you subtract. What's negative 4 minus 6? Negative 10. And what's b to the negative 10th? The same thing, right? What I'm basically trying to show you is you can't go wrong as long as you just do something. But you have to do them correctly. Like you have to either use the negative exponent rule where you move it to the bottom correctly. Don't move the 3 b's because that's already positive, right? As long as you're enforcing each rule correctly, it doesn't matter which rule you enforce first and which one you do second. Order doesn't matter with these. We good? How about the last one, 45? What'd you get for this one? So we got negative x squared raised to the 4th power over negative x squared to the 4th power. Wow. What do I have on top? What happens up here? What's going to happen to this negative? Do I flip negative numbers? That's just a negative number. What's going to happen to this negative right here when I have 4 of them? This negative is going to turn into a what? Positive, because that basically means I've got negative x squared times negative x squared, right? I've got 4 of those things. So because of that 4th power, this negative is going to turn into a positive. So what do I have on the top then? What do I do with the? Is this negative going to reason? Because just out in front, this means I have x squared, x squared, x squared, and x squared. So I still have x to the 8th on the bottom, but how many negative signs do I really have here? I only have 1. Oops, that's an 8. So what's going to happen to my x to the 8ths? They're going to cancel. What am I left with here? Anything divided by itself is what? 1. What's the answer to this question? Negative 1. Are we good with these? So real quick, on a scale of 1 to 5. 5 being, I'm going to ace this quiz tomorrow. 1 being, got me, I don't know what's going on. Flash at me. How do you do these? Okay. These are the types of questions right here. This one, that's exactly what your quiz is going to look like. That's all that's going to be on there. Just these. These and scientific notation. So your quiz tomorrow is basically got 2 types of questions. One, where you need your Cam, put your phone away, please. We need your exponent rules. What are those exponent rules? Anything to the 0 power is 1. If you see a negative exponent, you flip it. So it's 1 over, and then make it positive. What do you do with x to the a times x to the b? Add the exponents. What do you do with if you divide x to the a divided by x to the b? You subtract. What do you do with if you have multiple things like x times y raised to the a power? X to the a, y to the a, right? What do you do if you have x divided by y to the a power? Again, they both get x to the a over y to the a. Am I missing one? I feel like I'm missing one. Oh, powers raised to powers. X to the a raised to the b. You multiply. If you know your properties and you recognize, oh, I'm supposed to multiply here, I'm supposed to add here, I'm supposed to subtract here. Again, it doesn't matter what order you do things. Okay? Those are the first type of questions. Those are most of the quiz. And then there will be some questions where I'll give you that one. Ask you to multiply big numbers or really small numbers. And then next I will give you a big number like this divided by a big number or a small number. What do you do with both of these? Scientific notation. What's this number in scientific notation? Where do you want the decimal? Between the 1 and the 2. Times 10 to the 3, 6, 7. Times, where would I want the decimal here? Behind the 2. Which would be 1, 2, 3, 4, 5, 6, 7. Big number, positive. Little number, negative. What do I do with these numbers now? What do I do with the 1.2 and the 2? What's 1.2 times 2? Oh, what's 1? Just 2.4. You can do that in your head. What do I do with the exponents when I multiply? Add them. What's 7 plus negative 7? 0. Anything to the 0 power is? So the answer to this question is just 2.4. Yes? What do I do with this one, though? Same thing. So this one would be 1.2 times 10 to the 3, 6, 9, 10, 11 divided by 2 times 10 to the 1, 2, 3, 4, 5. So negative 5. So again, but now what do I do with the 1.2 and the 2? Divide, which would be 0.6 times 10 to the, what do I do with these two numbers now? Subtract. What is 11 minus a negative 5? Positive 16. Now, I want everybody to pay attention real quick. There is a problem with this answer. Now, I could put it in standard form, which would be 0.6, and I'd move it 1, 15, 16. Okay. But maybe I don't want to put all these zeros, which would be comma, 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 comma. If I wanted to leave this in scientific notation, is this number right now actually in scientific notation? In correct scientific notation? Why not? The decimal's on the wrong side of the 6, isn't it? Shouldn't it, if I wanted it in real scientific notation, shouldn't it be 6 times 10 to a number? Not 0.6? So the decimal's off by 1 spot. So the answer here is either 6 times 10 to the 15 or 17. We're off by 1. Which would it be? Well, 3, 6, 9, 12, 15. This is actually the correct answer. Sometimes when you multiply or divide numbers, the result isn't actually in real scientific notation. Sometimes we need to move it one fewer spots, right? Sometimes, you know, if it was something like, maybe you had to do 6.2 times 10 to the third times 2 times 10 to the 8th. When I multiply these, I get 12.4 times 10 to the 11th. Is this actually correct in scientific notation? No. Where should the decimal be? Between the 1 and the 2. So sometimes it's off by 1 after you multiply or divide. I want to move it so make this number smaller, right? If I make this number smaller, what do I have to do with this number to keep it equal? Make it bigger. These two things are the same number, right? This one's technically correct in scientific notation, and that's important because let's say I give you a multiple choice quiz tomorrow. If this was the question, maybe it didn't even start there. Maybe it started, you know, one more step above that, which was, this would have been 1, 2, 3 times, let's see, maybe that was the question. So you put it in scientific notation. You multiplied. This isn't an answer. Which of these do you think is going to end up being the choice in a multiple choice situation? The bottom one. So you're going to have to know, oh, I got this, but that's not one of my choices. All right, well, that means I got to put it in real scientific notation. Worst case scenario, figure out what that would be. Write out the 12.4 and move it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Put your zeros in. And then put it back in scientific notation. So now I want it as 1.24. How many times do I have to move the decimal to get it back where I really want it? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So worst case scenario, you could always do that. But I think it's easier just to think, if this number has to get smaller, to keep these two numbers equal, this number has to get bigger. On this one, this number had to get bigger, right? Which means this number has to get smaller. That's an easy way to remember it. Are we good with these? There's only going to be two types of questions on this quiz. Scientific notation questions. Either putting numbers in scientific notation, taking them out, multiplying or dividing with scientific notation. And then the other type of question is just going to be simplifying with exponents, using our properties. Are we good with these?